what is the first thing that we're probably going to need to do for this last problem? What did you say? What? I'm going to try to break this problem up into kind of 3 steps. And I'm wondering what you guys would think is the first step. Find the concentration of the guy we're trying to figure out the concentration. Okay, so we got that. And remember, we have basically, think of it as 2 beakers. One beaker with this in it, and another beaker with this in it. Okay? Now, does it matter what the Na and the NO3 do? Okay? So we're focusing on the Mg in there and the F in that. What was that? They're both 1 to 1. Yep, they're both 1 to 1, so that's nice. So we can find the initial concentrations of it. Start with our Mg. How would we go about doing that? What's that?
150 times
101.
That divided by 400.
150 and 250? Yep. Why don't you guys do that for the 4 and 2? Got an answer? What do you get for MG?
3.
Okay. Other one?
6.25 times 10 to the negative 2.
The purpose of finding that is to what? Find Q. Now, here might be the difficult part, not super difficult, but since there's so much information up there, what are we finding the Q of? What formula or what? MGF2, yes. So Mg is just 1, so I can just plop the concentration in there. F2, I have to raise it to the 2nd power. Right? Yeah, feeling well. Just a little bit of
Yeah, I have Bible tomorrow, and I have other lessons.
working on it.
Well, yeah, and lessons
For what?
for English.
Yeah, that's
Well, how long do you have to do them?
We got them like Tuesday, that was.
So you write 3. Okay. Full essays or like a page or what? This is average stuff.
It was with the physics professor we had. It actually wasn't that hard, like the material in general.
It's more busy work than
Yeah.
anything. Okay, what do we get for this?
1.46
Do I have a second on that? Is that right?
Yeah.
Okay, so how does Q relate to KSP?
It's great.
It's always.
Which means what?
Yeah.
Okay. Yeah, kind of. So, I'm going to kind of break this up into step one. Step one is figure out if the precipitate will form. That make sense? Step two is, the best way I would describe it would be step two is where we're going to, because we went past the K value, it's very difficult from the information past the K value to be able to find where equilibrium lies. And so what we're going to do is go all the way back to the beginning, assume it precipitates all out, and then do a regular equilibrium problem. So, what is our reverse reaction that we are going to focus on here?
plus 2F minus those two. Or no, is it the other way?
No, correct. Because we're forming the precipitate. So when I say we go to completion, what are we doing?
Going back.
Sure, we're going to do our stoichiometry, right?
Yeah. Yes.
Okay. So, what do I do?
150 times 0.01 per MB. And 250 times, well, that equals 1.5. 250 times.
Okay, what do we get?
1.5.
1.5 and what?
25 might difference.
Fast to be, goes down twice as fast, right?
Yep, so we do have to consider that, so maybe you make yourself a little note or,
Would it be easier just to divide the concentration by 2 right now?
Go
Would that
ahead.
make it easier, just to divide by 2?
be careful. Well,
0.5.
divide this by 2?
No, the 2F, because you're gonna get 12.5.
You could, yeah, I don't know if it would be easier, but
Same effect as subtracting twice as much.
yeah. So whatever you were most comfortable with. Okay, so minus 1.5 minus 2 times 1.5. I don't really care this because it's not even in the equilibrium expression. Okay? Now, I know that I have a lot of this F minus. Okay, so when we go over and do the equilibrium stuff, we're going to find that that's probably just going to be the important number for my F minus. But let's actually find what the molarity of that is. Divide by what did we say, 400? So I'll show you this when we're all done, but I'm pretty confident at our equilibrium concentration of F minus is 0.055. And I'll show you why when we complete everything. Okay, so that is step 2. Step 3,
So why did you find the concentration?
why did we?
But why not MG?
Well, I'll show you when we go through this. What ends up good, what is ending up good, can't talk. What is going to end up happening is you're going to have this number plus 2x, and x is going to be so small that it isn't going to affect that number. Mg we don't have any to begin with, so whatever x is what the concentration of Mg is going to be. Okay, when it says solve for equilibrium, are we talking about the precipitation equilibrium or the solubility equilibrium? Yes. We want to take this and flip it. I want to know how much is going to, essentially we're like redissolving it. And we kind of have a common eye on what is the concentration of one of my products over there. Well, that was the previous problem.
0.055.
We don't have any of this. Okay, plus x, plus 2x. So we have x at 0.055 plus 2x. What is the case? 6.4. 9 will be x times this plus 2x, but we're going to remove what? 2x. Don't forget to square it, because the equilibrium expression is going to be squared because of the coefficient. Solve for x. So, just to show you here, Andy, now, we would take that x, plug it in here to find what the equilibrium concentrations are, but that x is so small that when you add it to 0.055, it ends up being just 0.055. Okay? But we now know the concentration of Mg plus. And it's what? Is that it? Was there any other problems on here? That's the last one. That's the last one. So, what I would suggest then is breaking this up into kind of a 3-step procedure. Start by finding a precipitable form, okay? And then make sure that you do the reverse reaction, assuming it goes all the way to completion. And I was telling Annie this, but do you guys remember why we can assume it goes to completion? What did we do? I know, but what makes me assume that I can just react it back to all the way? You want to say? this is the K value for the solubility, right? If I wanted to find the K value for the reverse reaction, what would I do? 1 over. Well, that's going to give me a high number. What does a high K value tell you? It is far where? Far right. So, because it's far right, it doesn't actually go all the way to completion? No. But it goes close enough to completion that it isn't going to mess up our numbers super, or a whole bunch, that we can assume that. It's a safe assumption.
Because the other KSP is 156,000, sorry, 156,200,000. Yeah, a little high.
Now that doesn't, now we know that we still have some of this, but most of it is this. Okay? Questions on this? Sure.
Breaking into the 3 steps helped me understand it a lot. And I didn't know what we were doing yesterday, but today this makes sense.
Well, that's also the second time you've seen it, but yeah, it's true. I'll try to write things down in the step.
Compliment, good job, Kramer, I get it now.
Well, I'm not saying you're not, I'm just saying I'll try to break it down. Although I don't know if I always can.
Right.
Are you always gonna have one that precipitates, or are we gonna always have to do that just in case you miss?
I would always just in case.
Because like, otherwise, it's
We're
like,
always dead.
I'm just saying that because like, I feel like it's just.
Just ignore the first step.
Yeah, but then the one.
Well, the reason why I don't want you to ignore it is because what's likely going to happen on a test is I'm just going to ask you, will it precipitate form or not? And I won't ask you to do the rest of it. I might ask you to do one of these, right? For the sake of time, I can't have you do like 12 of them. But I might ask you to do like quite a few, not quite a few, but possibly 2, maybe even 3 of these, where 1 or 2 of them might be the opposite. That's possible. So, even though you might not need to do it if you know it's one of these problems, yeah, you might be able to assume it goes in precipitatable form, but just be careful with that. Thursday? What day is it, Friday? Yeah, test Tuesday.
I have an economics test Tuesday, but I don't want to take this issue then. Yeah.
I told you that we were going to take another day yesterday.
Wait, issue,